The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse. All food chains would be broken. And only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet. with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas Fault Line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and is called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, maybe too late for that, but I'll try, the ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland showed that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all that is salt water from the world's oceans. There aren't any borders between the four oceans we've all come to know, but oceanographers and the world's countries did traditionally split these waters into four distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the fifth body of water. It's called the Southern Ocean, and three of the four original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land, and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space of the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nios, in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metalworkers use. Duh. The air from the anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Moxstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future. The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, These devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust and, in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, it's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. a bunch of super brainy scientists with even brainier computers. The first scenario, a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored super ocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film, each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake. On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientist in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.